So I am recording. All right, so you want to grab out your notes and turn to practice 2. Here in practice example 2, they didn't give us the constraint equations, but that's totally fine because they gave us the graph. So the constraint equations, those are just going to be the equations that get us the graph. So if they give us the graph, not a huge deal if they leave off the equations. They did give us the objective function because there's no like word problem that goes along with this. So first they want us to evaluate the objective function for each vertex and then determine which vertex maximizes the function and which one minimizes the function. I believe that this is exactly like the mild on the test. We ask you for the maximum and the minimum. Okay. Oops. All right. So how are we going to do that? We're going to create a table. So even though on the test there's not tables given to you, I highly recommend using a table because it's a really nice way to organize your work. So we've got a table that they're going to give us X and Y, and we're going to then put it into the equation. Okay, I don't know what's happening with this stupid thing. All right, let's try and tuck these guys in so they don't keep touching the screen. Equals, whoopsies. Four X plus 5Y. So then we can just list out each of those points. We've got 0, 0. We've got 0, 8. We've got 6, 5. And we've got 7, 0. We're going to put those X and those Y values into the objective function. So for each of those, we're going to do 4 times whatever the X value is and 5 times whatever the Y value is and see what we get for our answer. That's supposed to be a 5. Seriously, the screen. There we go. All right, so we've got 4 times X, which is 0, 5 times X, Y, which is 0. So 0 plus 0 is 0. Likely that's going to be the minimum. Because do we have any negative values there? No, we have no negative vertices. So 0, 0 is the smallest, or 0 is going to be the smallest that you can get. So for the minimum, so minimum is going to minimize. That's going to be at 0.00, and that's going to give you 0 for the objective function. Okay. 4 times 0, which is the X, 5 times 8, which is the Y. That's going to give me 0 plus 40. Okay, it's definitely not the minimum, but we're going to have to see if it's the maximum. Four times 6, 5 times 5. Let's see what that equals. 24. plus 25, which is 49. So far, pink is the maximum. And then we have 4 times 7, 5 times 0. So we've got 28 plus 0, which is 28. So to maximize, that's going to be the pink. And that maximizes it at the value of 49. So again, in the mild question on the test, I do give you the constraint equations, but you don't really have to use them because I'm giving you the graph as well. So then what you're going to have to do on the mild is you're going to have to make your table. You're going to have to pick out the vertices. So here, I gave you what the vertices are. You're going to have to say what the vertices are. And there's one, if there's one that's like not exactly in a corner, then I'll probably give you guys that one just so that everyone's calculating the same number. Okay, so you're going to have to pick out those vertices. So you need to, again, know the difference with how to write an ordered pair of x comma y. Again, like I said yesterday, that's a learning standard that you guys started in 6th grade and have used every single year. By now, you should know that it's x comma y. Okie dokie. Now, with that being said, I will say that like on the test, when people made that mistake, if they had the right graph, what I think people's thought process is that they're thinking rise over run. So they're probably counting up from 0 and then over to the point where they intersect. And maybe that's why they're putting the y comma the x. But like at this point, you guys should know that you need the x number first. Okay, so on this particular thing that we just did here, thumbs up, sideways, or down. So what we just did, where they give us the points, they give us the graph, and we're testing those vertices to see which one gets us the biggest number and the smallest number. Okay? So if your thumbs up, it looks like anyone that's given me a thumbs is saying thumbs up. Then that means that for the test on linear programming, all of you should at least be able to get to a 6. Also, the checkpoints were not as bad as you guys thought. I did have some 5s, 5 out of 10. So I did have some 50%, but most people got like a 6 or higher. And a 5 out of 10, when you're talking the amount of points that we've had so far, is not going to like make or break your grade. It's only a 10-point checkpoint. And if you got half of them, it's fine. Okay? So I will give those back to you guys during class today. So, okay. So why do we do all of this? Why are we going through all of this? This is all written on your page. We kind of talked about this yesterday. So this can help businesses reduce costs. So that would be minimizing costs. They can help them improve their profitability. So they can say like, okay, we need to be at least in this range. We might not be able to maximize our profitability right now, but we know that we need to stay in this range to be like with our head above water, like to where you're actually making some money. You can reduce risks. You can use resources effectively. You can look at how many staff you have and how many hours they're working and what their productivity is. So all of these things, most companies, maybe not like a small startup company, but most companies have data analysts that work in those companies. So while it might not be everyone is using this, the data analysts are using linear programming to try to make the most money. Generally, that's what companies want. They want to make money. If they make money, they can have more employees because they can have bigger payroll. They're going to be making more money for everyone. So that it could be used for transportation, communication, finance, manufacturing, energy, health, and agriculture. Agriculture has a ton of math. So Belvidere being a big farming community, you might think that like farming is just farming. No. There's so much math that goes into farming, just even from the speed that you're harvesting your crops. Again, the expense that takes. So all of those things are all mathematical. So if you're like, I don't really care about math, but I want to go into business, math is going to affect you in business most of the time, okay? So, all right, last one for today. Now I did move all of this, and then it still is, I go off of the screen and it decides to move again. Super annoying. All right. So this is kind of in between a mild and a medium level question. Okay, so in the medium level question, you're going to have to graph yourself, but we're going to give you the constraint equations to do the graph. But you are going to have to come up with the objective function. Again, generally speaking, the majority of the time, the objective function is going to have to do with money and making the most profit or minimizing your costs the most. Okay, so Vanilla Bicycles runs 2 plants in Portland to manufacture their bikes. The company considers its constraints at each plant, such as general labor, machine time, technical labor, which is reflected in the graph. Plant A earns Vanilla a weekly profit of $60 per bike, and Plant B earns the company a weekly profit of $50 per bike. How many bikes should the manufacturer make in each plant to maximize the weekly profit? So again, if there's 2 plants, likely, like how many companies have multiple locations? The locations are not going to necessarily have that same profit margin. It could be for a lot of different factors. Maybe one plant is bigger, so it can have more employees, so they're going to be producing more. Another plant might be in an area that has higher rent costs. So then that's going to cut more into the profit of the company. So just because it's the same company doesn't mean that each plant would be making the same amount of money. So now for us to write this objective function, we have plant A earning $60 per bike. Because it says X is going to be the number of bikes produced by plant A. Yeah. Is it not on yours? It might be covered up by a box. Okay. So you can write that in. Plant B has a profit of $50 per bike. So $50 times Y, the number of bikes that are at plant B. So do you want me to make that bigger? So this one, I guess, is not, it was probably covered up on your paper. So X is the number of bikes produced by plant A, and Y is the number of bikes produced in plant B. Again, with most of these real world problems, you are going to have a piece that says that like X has got to be greater than or equal to 0 and Y has got to be greater than or equal to 0. One way of us doing that is just by giving you that quadrant 1 graph. Do you see how this one does have a little bit of quadrant 2, 3, and 4, but the whole shaded area is in quadrant 1? I'm going to just give you guys the quadrant 1. So you need to know that if you have your shading in quadrant 1, 0, 0 is basically always going to be a point that you have to put into your table. Okay? So you're going to do your origin, your y-intercept, your x-intercept, and anything else that's in there. Okay, so this one, we have 5 points to test. So if you have anybody still writing this down, that x stands for bikes produced by plant A and y stands for bikes produced by plant B, because I'm going to minimize that again and move it out of the way so that we have enough room in our table to put our 5 points. So now, Alex, did it seem like a crazy stretch for me to write that objective function? No, there was only 2 pieces of information about money in the word problem. So do I know that you all have the ability to write these objective functions? Absolutely. You guys were writing functions perfectly when we were talking about the systems of equations. So you guys have no problem pulling the necessary information out and writing an equation. Yep. Okay, so now I'm going to minimize this guy. Come on. So annoying. Whoa, that's really tiny. Oh well, I don't care. It's going to go away. Over there. Okay, I'm so glad that I chose black and then it's still writing pink. Okay, so we need to make our XY table to find out the profitability. So now this one asks specifically how many bikes should the manufacturer make in each plant to maximize the weekly profit? How the heck am I going to figure that out? I'll tell you, 0, 0 is not going to maximize profit. You're making no money if you don't produce bikes. So zero, zero, we've got I'm going to just fill this out to get ready for my points. My 5s are looking terrible on this board. And I'm picking up the marker. I don't know what the deal is. And the last one. Whoopsies. I need more space here. Okay, so for my 0, 0, it's going to be 60 times 0 plus 50 times 0 is going to be 0 plus 0. You're not making any money. That's not what we want. Purple. Okay, so 0, 500. Okay, plant A makes 0 bikes, plant B makes 500. So we've got 0 plus 25,000. That's a pretty good profit. 25,000. What about 300 and 400? $18,000 plus 20,000. Goodness gracious. 38,000. Those are all zeros. They're all in hundreds here, so. $380 and 200. $22,800. Plus 10,000 is 32,800. That one doesn't maximize. And my guess is anything that has a 0 in one of the plants is not going to maximize as well, but let's do the math and see. Oh, let's see. What color we want? Let's go with like a sky blue, like a teal. That looks like a good color. It's going to kind of blend in here. Geez, I picked like the exact color. All right, so we've got 400 and 0. I'll tell you right now, this one's not going to work because it's just 24,000 here. So which one maximized? This guy right here maximized. They're asking how many bikes should the manufacturer make in each plant to maximize the weekly profit. So they're not asking for the maximum profit. They're asking how many bikes do they need to make at each. So we have to interpret what the heck the graph means. Anybody have an idea how I'm going to answer that? What does X stand for? The number of bikes in plant A. What does Y stand for? The number of bikes from plant B. So when it says how many bikes should the manufacturer make in each plant to maximize, we need 300 at plant A and 400 at plant B. That is what our answer is. Because that particular vertice of X is 300 and Y is 400 is what maximizes the profit. Now, if they said, how much profit is the company going to make? Then your answer would be $38,000. Do you see how you really have to pay attention? Like, I say this all the time. So again, people who have had me before have heard this. Answer the question they're asking, not the question that you want to answer. Pedro, how many times did you hear that a lot out of me last year? Anytime we were working on word problems, I would say, answer the question they ask. Because people get done with word problems and they answer what they think that they want to answer versus actually going back and reading the question to make sure that you're answering what they're actually asking. It's like my home life. I will ask a question, and my youngest daughter and my husband will say something that is not answering the question. I'm just like, just answer the freaking question already. Like, I asked a question. It's either a yes or a no, or a this or a that. So this, make sure that you know what the question is asking. All right. Now, there are 2 or 3 questions. Can I borrow your packet? Okay, so they're asking you to answer what the vocabulary for objective function, constraints, feasible region, and vertices are. And then let's just do 5 and 6. So they give you the vertices, or you have to figure them out, but they're easy to figure out. So 5, they give you the vertices. 6, you have to actually like say what they are, but they're very clear. And then try to see what it says, determine what vertex will maximize the function and which will minimize in number 5, and the exact same thing in number 6. So this is a fantastic practice for the mild level questions. So you'll use the rest of class to do that. I know this is really vocabulary heavy, but like vertices are something that's not a new vocabulary for you. That one should be the easiest one for you guys to know, is the vertices. Okay, those are just the points basically on like the outside of the shaded area. Again, the constraints are the equations of how we get the graph, and the objective function is this, like what we just were plugging into in the table to figure out the profitability or the maximum and minimum. Okie dokie. So I'm going to continue to use that vocabulary, so you want to make sure that you're familiar with it. How many of you feel better about it today than you did yesterday? Okay. How many of you felt fine with it yesterday? It's just really vocabulary heavy, so that tends to make people nervous.